Hi there, it's Katie with TutorPug, and I wanted to do a continuation of my past two videos where we find the area of some regions between some graph, a left wall and a right wall. But in the earlier example, we were already given a picture, and that would allow us to visually see if we needed to put any portions of this area under absolute value sign. And now this would be an example of a quiz question or a test question where you're on your own. So the way we have to do this is, first thing, we're going to use the calculator a lot in this scenario. And the first thing we want to do is go to Y1, hit your Y equals key, and you want to enter the given equation. All right, so we've got x squared plus 7x minus 17. Now, this next part is critically important. If you don't remember this, everything from here on out will be a complete unnecessary battle. So this next step is critical. You have to remember it. You're going to hit your window key. And you want, on that window key, this lets you set the viewing window for the XY axis when you actually graph this. And we're gonna use the window key to our advantage a little bit. We want the far left x value to be -10. And we want the far right x value to be +3, because that's the left wall and that's the right wall, and that's really all we're interested in. And I'm just gonna go ahead and make my scale be +1. Now, don't mess with the y's. Don't worry about them. We're gonna make the calculator do the heavy lifting for us. So on this kind of problem, put this into Y1, hit your window button, very important, hit window, set your X-min to your left wall, your X-max to your right wall, and then hit zoom, top middle, zoom, and you wanna select zoom fit, which is a little bit farther down, it's zoom 0. And if I do that, if I hit zoom fit, the calculator will take the left wall and the right wall, and it will automatically adjust the y's so that I see what I need to see. Okay, so I have this lovely parabola, which looks like this. All right, we're being asked to find area. So we have to know that area means pieces above the x-axis area, or pieces of section that are above the x-axis are going to naturally be positive. So this little piece right here would be positive. This little piece right here would be positive, but this whole section that's between my curve and the x-axis will turn out to be a negative number. Area can't be negative. So I have to split this up into 3 different definite integrals. I have to have one that goes from -10 to whatever this exact x value is, and we'll use the calculator to find that. That's going to be one squiggle, one integral, and it's going to be automatically positive, so I don't need to put it in absolute value signs. Then I have to do a separate integral from here to this x value, and I got to find those. But that whole thing will naturally be negative, so I have to put that whole thing in the absolute value sticks. And then over here, this little sliver will be positive, so I've got to go from that x value to the right wall, which is +3, and that will naturally be positive. So the way we do that, first of all, we have to find this value. And we have to find this value, but we've got to do them separately. So I know that one of my antiderivatives, the area, is going to be from -10 to something. And what I'm doing right now is I'm finding that something. I'm finding this exact x value where this guy crosses the x-axis. So the way you do that, it's second and the trace button, or second calc, however you want to think about it. So I'm going to hit second calc, and I have this menu that pops up, and I want to select item number 2, which is 0, because where a graph crosses the x-axis, that's an x-intercept. It's also called a 0. So I want to select 0. And as soon as I do that, it takes me back to my graphing screen. But down here, my cursor's somewhere. It could land anywhere. You never know. But this, I'm going to get asked 3 questions down here on the bottom left. It's going to first of all say left bound. And then when I set the left bound, it's immediately going to say, what's the right bound? And as soon as I set the right bound, it's going to say guess. Well, what does it mean by left bound, right bound, guess? Left bound, right bound of what? Okay, if we're going to find this x-intercept or this 0, does it make sense that as you are looking at this curve, anything over here would be a little bit to the left of that point, and anything over here would be a little bit to the right? If you drew an imaginary line right there, this is left, that's right. So I got to scooch my cursor over so it's visually left of my target and then press enter. So we scoochy, scoochy, scoochy. Here we move along. And it doesn't have to be super close and it doesn't have to be super far. I'm going to put mine there and hit enter. And as soon as I do that, it changes it and it says, okay, great, thanks. I locked it in. What's the right bound? So we scoochy, 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 scoochy a little bit to the right of the target, which means below the x-axis, and I hit enter, and then the calculator says, would you like to guess exactly where that is? And I usually just hit enter and say, no, I bought you for a reason, you do the work. So now it tells me the answer. It says that the exact x-coordinate of this point, which I need, is negative 8.91. All right. Negative 8.91. So that's going to be one antiderivative. We do not put it in the absolute value sticks because it's already positive. So that will take care of this little sliver. This sliver, we're going to add that to this big chunk. Well, the left wall of this sliver is negative 8.91. Negative 8.91. Okay, now I got to find this value, which is the right wall. Which means, here we go again. I got to find that 0, that x-intercept, that 0. Second trace, 0. It wants the left bound, the right bound, and the guess, but now I'm going to have to say, okie dokie, let's slide all the way over here. The calculator is powerful, but it can only do so much, so it doesn't just magically give you a list of all the zeros at once. It's not quite that smart. All right, over here, there, that vertical line, that pencil line, that's my target. That's where the 0 is. So my left bound is now going to be over here, a little bit below the x-axis. Right bound means we're going to move cursor a little bit to the right, which means above in this case. And if I want to scooch a little bit closer and guess. So that particular x-intercept is 1.91. And since that whole big chunk from negative 8.91 to 1.91, since that whole piece of real estate is under the x-axis, if I don't force it to be positive, it'll come out to be negative. So that whole thing has to go in absolute value signs. And then we got to finish it out. We can't forget about this little sliver. So that his left wall is 1.91. His far right boundary is 3. And that's what I have to antiderive. This is kind of a gnarly one because we have 1, 2, 3 pieces, and we've got to account for each of them separately. But I'm going to get back to my home screen. I can do this all at once, left to right, using Math 9. So first of all, and I don't normally advise doing it all at once, left to right, but for the sake of time, I will. So I'm going to hit Math 9. I'm going to put negative 10 on the bottom and negative 8.91 on the top. I'm going to bump to the middle box. I'll use my quick key for Y1. Bump, that's an X. I'm going to add that to, now I've got to set up absolute value signs first, and remember that's under the math key, the number menu, ABS. We're going to take the absolute value of the integral, so I got to hit math 9. Your bottom bound is negative 8.91. Your top bound is 1.91. I'll use my hotkey again. Alpha, trace, y1, bump right, x. Get out of the absolute value sign, so there's a lot of minding your P's and Q's. Add that to another math 9. 1.91 is on the bottom, 3 is on the top, and we're still using the same y1 curve. And we hit enter, and ta-da, there's my number. That's the area. If you just anti-derived this from -10 to +3, you would get a number, and that number would represent something, but it would not represent the area, and you would be wrong. So area means you have to look at the curve, you have to figure out who's above, who's below, and whoever's below, you have to force it to be positive. Okay, go study, study, so Mr. A will be your buddy.